Hello friends, welcome to Sri Jayendra's Rank Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 9 of a unit motion in a straight line. So let's begin with this class. In this class, as we have discussed previously, that this is the class for the numericals only of the graph. As you might remember that we have gone through three different classes of the graph previously. Our first lecture of the graph will cover the slope of the graph. Our second lecture was covering the area of the graph, and third lecture of the graph was covering the different aspects of the graph, that whether it would be a straight line or whether it would be a curvature and that kind of thing. So we have done all the things that I need to cover in the graph. Now today we are going to discuss about the previous year asked questions based on the graphs. So let's begin. But before we move to the question, I request you to take your pen and paper and do questions with myself. So we both are doing the questions and we will just check that our answers are matching or not. So please be ready. Take your pen, paper. Are you ready? Are you sure? So let's move on. First question. Go through the data carefully. That the people have given that a displacement versus time graph of two moving particles makes an angle of 30 degree and 45 degree with the x-axis. You need to find out the ratio of the two velocities. That this is the graph for the displacement, this is the graph for the, this is the displacement, this is time, and they have given the graph for the displacement versus time. And let's say this is particle number 1, let's say this is particle number 2, and you need to find out the ratio of their velocities. Now first thing that came into your mind is that which graph is given. Yes, it is a graph of displacement versus time. Shall I write this? That's a displacement versus time. A next situation would be a velocity versus time, and very next situation would be the acceleration versus time. So you have given the displacement versus time, and you need to answer the velocity versus time. So you need to move forward. You need to move forward. If you want to move forward, what would be the option? Whether it would be a slope or it would be an area. Yes, you assume it correctly. It is a slope. So what are the options we are having for the slope? Let's write it down here. It is one of the option is delta y by delta x. This is one of the option. A second option is the dy by dx, and the third option is the tan theta. Now tell me which one best suits to you. Yes, in this case tan theta can be replaced because we are having a value of theta. But before we go, tell me from where we are going to measure the theta. From where we are going to measure the theta? Yes, from the x-axis. From the x-axis. So what I can write is velocity of first particle divided by velocity of second particle. It is a tan theta of first particle divided by tan theta of second particle. Now tan theta of first particle, it is 30 degree. It's a tan 30 degree, and tan theta of second particle, it is a 45 degree. Now what is tan 30? What is tan 30? Yes, it is root 3 by 2. And tan 45, it is 1. Tan 45, it is 1045 is 1. Yes, so you need, your answer should be a root 3 is to 2. Are you sure? Yes, yes, no, I made a mistake. What is value of tan 30? What is value of tan 30? Yes, it is 1 by root 3. It is 1 by root 3, and tan 45, it is 1. So this would be the answer, 1 is to root 3. Are you sure with this? Are you? Are you sure? Yes. Let's move to the same question of this kind, but I will modify certain thing. It is the same question, that displacement versus time. A graph is given for the displacement versus time. This is particle 1, this is particle 2, and what they have given is this is 1030 degree, this is 45 degree, and they have asked that find out the velocity of first particle to the velocity of second. Now analyze the situation, what we can do. Again the same thing, what is given, that I have been given that velocity was displacement versus time is given. I need to find out velocity, so I need to move up forward. While I move up forward, I need to find out the slope. These things must be clear in you, in your mind. For slope you are having a three options. One is delta y by delta x, this is first approach. A second approach could be a dy by dx. A third approach could be a tan theta. Which one suits to you? Yes, you must go with this approach. If you go with this approach, if you go with this approach, so v1 by v2 should be is equals to tan theta of first graph to the tan theta of second graph. But before write it down anything, please look at this carefully. These are the angles that has been given from the y-axis. When we considered an angle, we considered always angle from the x-axis. This is from y-axis. So what I need to do is, I need to just convert this angle according to the x-axis. But it does not make any difference because this is 45. So this would be the 45 itself. Yes. And this graph, this would be the 60 degree. This would be the 60 degree with the x-axis. So are you sure? Are you done with this? Yes. So now what is tan theta 1? It is tan 45. What is tan theta 2? It is tan 60. Now can you write down the values? Tan 45 it is 1. And what is tan 60? What is tan 60? Yes, it is root 3. So this would be the answer. Are you done with this? Are you? Are you sure? Okay, let's move to the next question. Let's move. What is given? Read it carefully. Which of the following cannot be, read this word very carefully, cannot be the distance versus time graph? These four options are given and I need to just check it out, that which option cannot represent distance versus time graph. Now tell me which of the options are there which cannot represent the distance versus time graph. Can it be a first option? What first option is saying? That as soon as time is increasing, distance is increasing. As soon as time is increasing, distance is increasing. Yes, this could be the situation. Second, this is the situation when it is moving with constant velocity. Velocity is constant. And when velocity is constant, a first situation could be there. In second situation, as time is passed on but distance is not. But this could be the case when object is at rest. This could be the case when object is at rest. Again, this would be the same situation when velocity is constant. Velocity is constant. Only the difference between these two, situation 3 and situation 1, is that in first case object has not started from the origin. Object has not started from the origin, and here object has started from the origin as x equals to 0 and at t is equals to 0. Here in the beginning of time, object may be at rest and then he has started moving. Here in this case at t is equals to 0 second, it has started the motion. But what would be the fourth option? Look at this. As soon as time is increasing, distance is decreasing, as this graph shows. Is it possible that distance could be decreases? No, this is not possible. For distance versus time graph, this is simply not possible. I hope you understand these things. Okay, but if listen me carefully, if fourth option, would it be possible if they have asked displacement versus time? Would it be possible if they have asked displacement versus time? Yes, absolutely. Because there might be the cases where displacement would be decreases. Displacement would be decreases as time is going on. But in this situation, they have asked about the distance versus time. They have asked about the distance versus time, and we just stick to it. So fourth option would be the answer. This three are the correct, and this cannot be possible. So fourth would be the answer. Are you sure with this? Are you? Are you sure with this? Yes, as this is not the possible, this would be the answer. Yes. Okay. Now let's look one more thing. Let's look one more thing regarding the graph. Suppose a certain quantity has been plotted, just as y versus x, and we have given a different situation. I should say a different location. Let's say this is location A, this is at top location B, this is at location C, this is location D, this would be E, this would be F. And I have been asked that what would be the value of a slope. That means we need to find out whether slope is positive or negative at different locations. So what you need to do is you just make a tangent over there and find it out that whether slope is positive or negative. Let's say suppose this is A. Here tangent is there. This is the theta. Here theta is positive. So slope at A would be greater than 0. This is location B. It is a straight line. It is a straight line. So slope at B equals to 0. This is the C. This would be the theta. And as this would be the theta, this seems an obtuse angle. As it is an obtuse angle, it would be less than 0. Here this is D. This is D again. This is an obtuse angle. So this is less than 0. E. It is a straight line. So slope at E would be equals to 0. And as this is an F. As this is an F. Here theta is positive. So it would be a greater than 0. What you can do one more thing is you can remember that if your particle is having a tendency to move upward it would be having a positive slope, and if your particle is having a tendency of moving downward, then slope will be a negative. Are you done with this? So let's look at the question based on this. What they have given is, go through the data very fast. That they have given is that displacement versus time graph is given for a moving particle, and you need to find out the instantaneous velocity of the particle is negative at the point. You need to find out the instantaneous velocity at which point velocity is negative. Yes, what could be the situation? Let's check it out for every situation. Let's check it out. At C, at C, that slope at C would be greater than 0 because it is moving upward. Slope at D, it is 0. Yes. Slope at F, look at this, this is greater than 0. Now check about the E. Make a tangent over here. This is an obtuse. This theta is obtuse, and as theta is obtuse, that slope at E would be less than 0. This is negative. So E should be the answer. Yes, what was your answer? Are you doing this with me? Are you sure? Was this your answer? Great work. Let's move to the next question quickly. Next question. Go through this. A displacement versus time has been given, and what you need to find out is ratio of magnitudes of the speed during the first 2 seconds and the next 4 seconds. So basically you need to find out the speed. Basically you need to find out the speed. So when you consider you need to find out the speed, you must remember that you are interested in magnitude only. That's why they have said it's a speed, not an this velocity. A graph is given of x versus t. You need to find out an velocity. So what will you do? You will move up forward or backward? Yes, you are correct. You need to move up forward. If you need to move up forward, what was your answer? It would be a slope or it would be an area. Yes, you need to find out the slope. So let's check it out. What are the options to find it out the slope? What are the options to find it out the slope? A first option would be delta y by delta x. A second option would be a dy by dx. And the third option would be tan theta. This all task has to be done in the back of your mind. So which option best suits to me in this situation? You need to find out speed in this 2 seconds and speed in last 4 seconds. Yes, you can choose the delta y by delta x. You can choose the delta y by delta x. So let's say for v1 it's a velocity of first 2 seconds. It's a y2 minus of y1 divided by x2 minus of x1. So y2, let's say this is 40, minus of y1, this is let's say 0, divide by x2, it is a 2, minus of 0. So this is 20 meter per second. Half of the task has been done. Now let's say v2, again the same thing, y2 minus of y1 divided by x2 minus of x1, but you will do this in mode because you need only positive value. So let's say this is 0 and this is 40. So this would be 0 minus of 40 divided by x2 minus x1. This is 6, this is 2. So this would be a 4. This would be a 10 meter per second. So if I take a ratio of this two, if I take a ratio of this two, my answer would be this. v1 or v2 is to v1, that is what we require. It's a 10 divided by 20 and answer would be 1:2. Yes, what was your answer? Are you sure? Let's move to the next question. What they have given for the displacement versus time graph as shown in figure, the ratio of the magnitudes of this during the first 2 seconds and the next 4 seconds. So can you do this? Are you sure? Okay, let me know what you will do. Let me just know very quickly what you will do, what you are supposed to thinking. That what they have given displacement versus time, what they require a speed, what is needed to be done. Yes, you are correct, you need to find out the slope. So how could you find out the slope? How will you find out the slope? Yes, for v1 and v2, this is delta y by delta x, and again this is delta y by delta x. Now I hope you will manage to do this. Yes, so I just write it down, do it yourself. Yes, let's move to the next question very quickly. Let's move to that. Go through the question, what they have given, what all they have given. They have given the velocity versus time graph, and they said that total distance covered by the particle in last 2 seconds of its motion is what fraction of the total distance covered by it in all the 7 seconds. So you are interested in two kind of motions, that you are interested in total distance covered by the particle in last 2 seconds of its motion to the total distance covered by a particle in the all the 7 seconds. So before we go through this, please let me know that what kind of situation is they have velocity versus time. and they have asked about the distance. So you need to move a backward. You need to move a backward, and when we move a backward, we need to find out an area. These things must be clear in your mind. These things must be clear in your mind. So now let's segregate this into different areas. This is A1, this is A2, and this is A3. I hope you are clear with this. So now, how can I calculate the value of area 1? Area 1 is, look at that, it is a triangle. Started with the 1, ended with the 3. It's an 1 by 2 multiplied by base, it is a 2 multiplied by height, it is a 20. So this is area 1 is 20. Now turn to the area 2. Let's look at this. Here it has been started with 3 and it has been ended with 5. So their base is of 2 and and height is of 20. So 2 into 20, it would be a 40. And last but not the least, it's an area 3. They started with the 5, ended with the 7. So 1 by 2 multiplied by 2 multiplied by height, it's a 20. So this would be the 20. Are you done with this? Are you? Are you done with this? Are you sure? Okay, great. Now, what should be done? You have been asked that distance traveled in the last 2 seconds. Let's say, let's say distance traveled in last 2 seconds, and you need a fraction of that total distance covered by it in all the 7 seconds. You need to find out this. So let's move to the next slide and do this. Distance traveled in last 2 seconds, that is basically area 3. In my graph it was a 20 meter, and total distance traveled should be is equals to area 1 plus area 2 plus area 3. Now let's look at the value of them. It's a 20 plus 40 plus 20. This would be a 20 plus 40 plus 20. So this is 20 20 40 40 40 80. This is 80 meter. Now you need to take a ratio of this. Let's say this as an x1, let's say this as an x2. So if I perform x1 is to x2, this is 20 is to 80, this is 1/4. That means distance traveled in last 2 seconds is 1/4 time of x2. Yes, what was your answer? Is it the same? Are you sure? Great, great going. Do it fast. You are doing good. Well done. Keep it up. Next question. Go behind this. What the data is given, that acceleration versus time graph is shown in the figure. The maximum velocity attained by the body will be. Now what they have been asked, what all they have given, that they have given you the graph of acceleration versus time, and they have asked about the velocity. So let's start with our situation. X by t is v by t, and next is the a by t. So what you have been provided, you have been provided with this a by t. What you require, it's in velocity, so you need to move up behind, you need to move up backward. If you need to move up backward, if you need to move up backward, what will you find? Slope or area? Yes, you are correct. You need to find out an area. Now find out the area of this triangle. This area will be 1 by 2 multiplied by base multiplied by height. This is 11. This is 11 multiplied by 10. So this is 5. 11 5 this is 55 meter per second. This would be the answer. Yes, very easy, you know. So let's move to the next question. Which of the following cannot be the speed versus time graph? Which of the following cannot be the speed versus time graph? Do it yourself. I'm not supposed to do it. Are you doing it? Are you? Are you doing this? Okay, let me help you. What they have been asked, that cannot, which graph? Speed versus time. They are asking about the speed versus time. Now let's check that, could this be possible? Yes, this could be the possible, as time is moving, speed is increasing, at a certain time speed is 0 and then speed is decreasing. This is quite possible, so this could be done. A third option, is it possible? Yes, even this is possible. Yes, even this is possible, that acceleration is constant, है ना, and acceleration is constant and things will be done. Fourth option, is it possible? Yes, is it possible that acceleration is negative and speed is decreasing with time? Does the second option is possible? If not, then why? If not, then why? Why this is not possible at all? Do one thing, make a projection at a certain time. So if I say here it is having a 10 meter per second, and if I say it is here having a 40 meter per second, so a particle is having a two speeds at the same time. Let's say this is a time of 2 seconds. So can I say that my particle is moving with 10 meter per second as well as 40 meter per second at a time of 2 seconds? This is illogical. This is cannot be done. A particle cannot have a multiple speed at the same time. A particle cannot have a multiple speed at the same time. So this could not be the option. This, as this could not be the option, this would be the correct answer, because they have asked that which can is not possible for speed versus time, which is not possible for speed versus time. Yes, let's move to the next question. Go behind it, what they have given. Go through this. What they have given is a graph of an object. Motion along the x-axis is shown in the figure. The instantaneous velocity of the object at point A and point B are VA and VB respectively. Then you need to find out the relation between VA and VB. Okay, this is location A, this is location B, and you need to find out their velocities. So first thing, when I look at the options, I can assume that in these two situations they want to say that velocity of A would be higher or velocity of A would be less or something like that. So first tell me, what is the velocity? They have given distance, they have given time. You need to find out a slope. So if I find a slope, it is an angle theta. Let me change the color. Yes, if I find a slope, this is the value of an angle theta, and if it is an angle theta, find slope. As I find that slope is constant, that means I must be sure that VA must be equals to VB. That means this could not be the answer. So if you look things like this, that go through the options and just eliminate those which are incorrect, this will help you. Now you need to decide between these two options only, that which could be the answer. You need to reconsider the questions. Now you need to find out the slope. How can you do this? It's a delta y by delta x. So what would be the value of delta y? It is 10 at the initial, 0 at the ending. This is 10 minus of 0, divide by, what is the delta x? It's a 20 at the ending and 0 at the beginning, so this is 20 minus of 0. So this is 10 is to 20, and if it is 10 is to 20, it is 1 by 2. 1 by 2 is 0.5. So this would be the correct answer. Yes? Will you be able to solve this kind of questions? Are you sure? Are you sure? Let's move to the next question. Go through this very carefully. A very good question is there. What they have given is distance traveled by a body moving along a line in the time t is proportional to the t cube. You need to find out acceleration versus time graph. So, if you wish, you can go through the question one more time. What they have given is that distance traveled by a body is proportional to the cube of the time, and you need to find out acceleration versus time graph for this situation. So what can be done? So let's look. They have given that distance is directly proportional to the t cube, and you need to reach up to the acceleration versus time. What can be done? What can be done? Shall I provide you a hint? Do you know differentiation? Do you know it? Yes, you might assume it correctly. That if I write is that x is equals to k into t cube, and let's assume that k is equals to 1 for understanding purpose only. Then if I am having a distance, if I differentiate it once, I will be having a velocity which would be a d by dt of t cube. This is equals to 3t square. But this is up to the velocity only. I need to reach at the acceleration. I need to differentiate that one more time. This is dv by dt. That would be d by dt of 3t square, which will give me a 6 into t. So if I write as in proportionality symbol, a is directly proportional to the t. This would be the situation. A is directly proportional to the t. Now let's back to the question. My relation would be look like this. Acceleration versus time would look like this. Now tell me which could be the situation. As I can see, acceleration inverse, time is having a power 1. Both are having a power of 1. As both are having the same power, it must be a straight line. This could not be the option. Yes, acceleration is changing with respect to time. As soon as time is increasing, acceleration must be increasing. So this is the only correct option, because this shows that acceleration is constant. This shows that acceleration is constant, which is not the case. This shows that acceleration is constant, but it is decreasing. So this could not be the case, and this could be the correct answer. Yes, are you sure with this? Are you? Okay, let's look at this. What we have done, we have a relation of x and t. We differentiate it twice and reach to the acceleration. This is very easy. Okay, so shall I add one more question here? If they have been asked that what would be the velocity versus time graph, what would be the velocity versus time graph, what it would be? So look at here. It should look like this. V directly proportional to the t square. It should look like this. Velocity is having a power of 1. Time is having a power of 2. As it is having a power of 1, it is having a power of 2. Both are having a different powers, and if they are having a different power, it could not be a straight line. And if it could not be a straight line, it must be a curvature which will protect the one who is having a lesser power, and V is having a lesser power, so I need to protect it. Yes, this would be the correct answer. Yes, you enjoy this session. Let's look at the next question. What is given? Go through this very carefully. That they have given is velocity versus displacement plot of a body moving along a straight line is as shown in the figure. The corresponding plot of acceleration a as a function of displacement x. What they have given is they have already given a velocity versus displacement, and what I need to find out is acceleration. I need to find out the corresponding plot of acceleration as a function of displacement. So this all are the acceleration versus displacement. This are a, this is a versus x, this is a versus x, this is a versus x, and this is the given in the question. So let's look how it should be going. This is velocity and this is displacement, and their graph look like this. Something like this, and this is 100. Now I need to go to the a versus a and x. What could I do? When I find out the two relations of acceleration having a differentiation term, it is a is equals to dv by dt. It is a is equals to dv by dt, and the next is a is equals to v dv by dx. A is equals to v dv by dx. Are you done with this? Are you? Are you sure? Yes. So first thing, with which I should use this question? This is with respect to time, this is with respect to position, or with respect to displacement. Yes. So this would be the correct option. Yes. Up to this, are you comfortable? Up to this, are you comfortable? Now, now, one more thing. What is dv by dx? What is dv by dx? Tell me. Yes, it is the slope. It is the slope of the graph. This is the slope of the graph. Now, if I segregate this sections into two slopes, into two parts, then for first part, this is theta, that m1 slope of first line would be a greater than 0, and slope of second line would be a less than 0. Slope of first line would be a greater than 0, and slope of second line would be a less than 0. So if I consider that a is equals to v multiplied by m1, and a is equals to, that means after 100 meter, this is, let's say a1, this is a2, v multiplied by m2. Yes, where m1 is greater than 0 and m2 must be less than 0. This is the situation that we know. This is the situation. So now look at the graph again. Let's first check it out. Here in this situation, both are moving in the forward direction. Here in this situation, both are moving in the positive direction. This could not be the case. In this case, both are moving in the negative direction. It is the a versus x, it is decreasing, even this is decreasing. So in this situation, as you can see it, that velocity is increasing, and if it is multiplied with the positive number, it must be increasing, but they are decreasing, so this could not be the case. Here it shows it is a constant, whatever the distance could be or whatever the displacement could be. This is simply not the case. So this would be the correct answer. A very good question. And you can assume it that, look at this, this is positive, yes, and this is in a negative zoner, because this number is multiplied with negative of slope. So are you sure? Can you handle this kind of question? Are you? Okay, let's wind it up here. So this all are the questions based on graph only. There are many other questions too in your practice sheets. Please do it, please do it. We have done whatever we can do for the graphs. So now please do one thing, that which topics are covered. Let me just summarize this. We have started with the motion and rest, then we have moved to the average velocity and average speed, then we have moved to the instantaneous speed. We have done up to the differentiation, so now we know all about the differentiation. Then we have switched to the graphs, and now we all know all about the graphs as well. So we are on a completion of 60 percentage of this unit, because we have been left with the equations of uniformly accelerated motion, motion under gravity, integration, and relative velocities. But 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 you need to practice all those topics which have been already covered. Please do it, because this is heart of an physics. So please make as many questions as you can do it. Thank you, and bye bye. Take care.